Okay. And then, hmm, let's see here. I can pick. Yeah, here we go. Okay. Yeah, let me try this. Let me share screen. Share sound, screen, desktop two. Okay. Okay. Do you see a whole bunch of small slides?
Yes.
Great. Okay. So I'm not going to go through everything. I just wanted to just drop in and pick a few things. But basically, um, have you heard of this notion of called the wicked problem? Either of you, wicked problems?
No.
No. So so let me just talk about it first in words, and then we can go back to the slide. So wicked problems are problems that you can't solve. Actually, they're wicked. So, but there are other features, like big problem, like global scale problems. So, what would you say right off the bat? Are some like big, enduring social technical problems that we face? What would you say?
Did you say
Social
socio-technical?
technical, social or technical or environmental problems.
Um, hmm.
There's equity. No person is
Yes,
ever equal.
equity. Yeah. Another, that's a social one, right? What's another one?
Um, kind of along similar lines, but um, like poverty or
Poverty.
wealth gaps, I guess.
Yep. Equity. These are social and economic ones. How about other kinds of really like things that problems that we face that are have been there for generations or centuries? Yeah.
Like conflict, I guess.
War.
War.
War. Okay. Look at the Ukraine war, for example. Um, and what about something from nature or from environment?
Uh, climate degradation.
That's it. Okay. Big ones. War. So United Nations, right, is probably the most globe spanning uh, system of governance. It doesn't have absolute power; it only has partial, right? But it's one of the organizations that tries to deal with these things on a global scale, right? So, but they happen over and over again. That's the thing. There's for centuries there have been conflicts, right? And for centuries there's been inequality in all sorts of societies, um, things like that. So these are wicked problems. These are examples of wicked problems. I mean, a kind of finite problem would be what's two plus two, right? So it's not five, but you can solve it. Or you can make a very complicated problem that's still solvable. You know, build a bridge over this river. Hard, complicated, people can make mistakes, but you build a bridge, right? Very complicated, actually. It takes a lot of generations of knowledge on how to build bridges. But bridges get built. It's not like, you start building a bridge, you never reach the end.
Mhm.
As you go. So the way that this notion got started was in business circles and in emergency management, these kinds of areas where, let me share screen now, where people whose job it was to deal with very complicated problems saw that there's a category of problems that you just don't solve. Okay, you have to do, for example, why? Because if you try to solve one, for example, here, every solution can cause more problems. You know, like you take example, I think in the news recently there was this right now today, there's something going on in Armenia, Azerbaijan, wait, ex so former Soviet republics, Eastern Europe. Um, And there's apparently there's do you know the story right now? The news story. I don't know if you followed any of this. Have you heard about this issue going on right now, this week, today,
No, not me.
in Azerbaijan? So there's a country over there. Oh, first of all, um, there's a country, Azerbaijan, that's next door to Armenia, and these two little countries that are, I think, bordering Russia, so a bit to the south,
Mhm.
and in they've been fighting over generations. Okay, um, border conflicts. But there's a little enclave of Armenians, ethnic Armenians, inside this country, Azerbaijan, um, and Azerbaijan wanted to basically and completely take it over under their, as part of their nation. But the Armenians living there didn't want to. They wanted to stay attached to Armenia. After all, they're Armenians. So there was a war not too long ago. A lot of people have been killed. A lot of soldiers have been killed over the last few years. I'm just giving a very quick summary. United Nations went in, et cetera, et cetera. But the countries are lining up on two sides. There's really no way to easily resolve this. And one of the problems is that over generations, the divisions, cultural divisions, become sharper and sharper. People used to live, next door to each other, literally next door to each other, of different religions and different cultural um, uh, identities. Uh, but once fighting got started, families lose a husband or father or a son, right? So neighbors who are from different ethnic groups start to start to embed, enmities, hatreds that last for generations. Okay, so this is serious. These are the real issues, okay, real problems, right? But if you try to solve it by bringing in, let's say, troops from another country, whether it's from Russia, because Russians are very much dominant over there, or from the United Nations, the other side will say, no, we don't want that. And yet, if nobody steps in, the skirmishes continue. Okay? You can't not do anything, but if you do something, you're going to cause more hatred. Okay? So that's a real problem. These are real examples of wicked problems. All right. So introducing troops from the outside might cause more problems downstream. It might stop the current fighting, but might as soon as when you let go, when you pull troops back out, people start fighting even worse. Another one is that you might have a solution like for climate change. People are talking about, I don't know if you've read some stuff at ASU, particularly for solutions that people have proposed for global warming. Have you heard of some engineering techniques for solving global warming? Some big moonshot type engineering projects. Have you heard of some ideas?
Not necessarily. I guess most of the news that I receive is about like just curbing our usage of different fuels.
But just some kind of sounds like science fiction type solutions that have been proposed. And ASU is a big developer of some of those big solutions. So can you sort of speculate what might be a big science fiction type solution to global warming?
I know ASU has a lot of plans in regard to water, but
Like what?
I don't remember. All I remember is hearing that ASU and water is a big thing. But
Yep.
That's all I got.
Well, here's something like, if there's global warming, all right, and Earth is getting hotter and hotter, so you can think about where's all that heat coming from? A couple sources, okay? So what's one source? One big source.
A source of global warming, like methods of transportation.
Yep, cars. Okay, cars and factories. But there's another big source of heat on this planet. The biggest source of heat on this planet outside humans is what?
The sun.
So one solution say, okay, have fewer cars, burn less oil, right? An obvious thing, giant thing, but lots of political issues. But another solution The second one, what might we want to do? Science fiction.
Block out the sun.
Exactly. So that's been a proposal
Oh
to block
gosh.
out the sun. Yeah.
Imagine that
So
would be bad.
so for example, what are people proposing? Some people are proposing to seed the clouds, to brighten the clouds in the atmosphere so they reflect more sunlight back into space.
Hmm.
How would you do it? Well, you pump all these chemicals up there into the clouds that have I don't remember what the chemicals are, but they're shiny. They reflect light. Okay.
Hmm.
Now, can you just imagine what might happen if you pump all sorts of chemicals into the sky after a couple of decades? What might happen? We don't know. Okay,
I
but
mean,
what might
yeah, we
happen?
already have the concept of acid rain. So
Yep. Smog, acid rain, da 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 da.
There's this movie, I think it's called Snowpiercer, and it takes place in like 2030. And essentially it's like the government had decided to drop a bunch of, cooling agent chemicals into the air to, reduce the temperature of the earth. And it like never stopped. It was
Yeah,
infinitely cooling,
yeah,
so it was unlivably cold. I don't know if you've heard of that movie, but
yeah. Yeah. I remember that. It's a pretty violent movie too.
oh
But
yeah. I
oh my
didn't get
God.
through more than 5 minutes of it because I was not a fan of the violence, but the concept was
Yeah.
interesting.
Concept is there, right?
Uh-huh.
So that's an example where a solution to this problem might seem like, oh yeah, sure, let's brighten the sky. So the clouds and we're done. But after maybe 50 years, who knows what happens? What might come down, right? Solutions might become more problems. Another one is that maybe you have a solution for, let's say, conflict in a certain country, and it might involve, well, I don't know, bring in some religious leaders, and maybe that'll work. Maybe if you have the Pope visit a very Catholic country, maybe he has enough symbolic power to, persuade people to drop their weapons. Who knows? But maybe if you put the Pope somewhere else, it won't work. It just won't work. If you put the Pope in England, which is Anglican Church, or put the Pope in China, probably won't, have the same effect. So solutions don't generalize. Can't just say, oh, this worked here, so therefore it'll work somewhere else, even if it looks like a similar situation. Another situation with another characteristic of wicked problems is that you can't test it ahead of time. Like with the planet Earth, right? There's no laboratory version of the planet to try this out. And also you can test things in the lab in a test tube with chemicals and shake it up and pump UV at it. But it's not at all like the real planet's atmosphere with oceans circulating and people putting factories in the ground and who knows what. So the only way to test the solution is to actually do it. So you can't rehearse. Um, and one my favorite actually is this one. I think you already saw it. It's the last one. The people who are trying to solve the problem may be part of the problem.
Mhm. And I mean,
And we
it's
know
only a problem for us technically, like say climate change. The Earth will keep on spinning with or without us, but it's us who think that climate change is a problem. So
yeah,
it's another.
and it is a problem for us. The issue is that what do we do about it, right? Um, so yeah. So, but then there's a one big master wicked problem is what we've been talking, what some of us have been looking at, which is suppose we manage to get all these people together, experts, right? Policymakers, people with money, investors, companies, foundations, banks, everything. And everybody comes and with all the goodwill, all right? Nobody's trying to game this situation, let's say. But if people come with different value systems, get somebody from the church, somebody from the mayor, somebody who's a citizen's representative, uh, a single mom, just single mom, a teenage kid, a journalist. They're going to come with different values, right? I mean, Morgan, you're a school government, expert pro, let's say, right? We know this. People come with. You can't assume, right? In reality, that people come to a room with the same values. So the master of a good problem that some of us are thinking about in complexity um, is if we bring people together into a room who have, we can't assume they have um, shared values, and we shouldn't actually, there's diversity of values. Um, then even people of goodwill, if they don't have shared values, are going to reasonably disagree on what's to be done. Just following your standards of what's fair, what's just, blah, blah, blah. Get faced with the situation, it can well be that this person will disagree with that person on what to do. So that's the master wicked problem. Okay. So here, the next slide I wanted to share with you is this one. Now, that means that we can't write down a formula. We can't put in a spreadsheet, do the numbers. We can't just have a logical proof that will satisfy everybody. This is just from the complexity of real life. Okay. But maybe the idea isn't to solve a problem like a math problem. The wicked problem doesn't get solved, right? You can try to make it better, but it's dangerous to think about a final solution. That's what I think. Okay. So the example I point to is from theater, from ancient theater in ancient Greece. And this is a theater, a very famous one, Epidaurus. It's at the bottom right of the screen. If you haven't been to travel in that part of the world, once in a life it's worth doing. Okay, I don't know either of you have traveled to Greece.
No, not yet.
But yeah, but there are other places in the world where people have built collective spaces for performance, for sure, of course. This one happens to be from about 2,500 years ago. Okay, and it's so perfectly built that if you stand there, I think I've been to this one or someone like it, where literally you can take a little nail or pin, even stand in the middle of that circle, drop it, and you can hear it way at the top. It's got amazing acoustics. So people used to perform, give theater perform theater thousands of years ago with no amplification, and the whole city would gather in that circle, in that stadium, to see the theater. And what I say is that the kinds of theater that people perform, of course, there are many comedies and tragedies and different kinds of satirical works too. But there are pieces of theater that people can read even today that are, we call them tragedies, okay, where the characters have conflicts, right? But the conflicts do not get resolved. They're not resolvable. But people would still gather there to see the play, to see the theater piece, to see how that gets worked out. At the end, the conflicts are still there. All right. Whether it's loyalty to the gods, loyalty to the state, the king, or loyalty to the family. And these loyalties in the famous play called Antigone were never resolved. Okay. And it's a tragedy. So people go away with this exposure to a situation like that. And I think the reason why they performed these over and over again was they gave people something of value. People felt a way to deal with these kinds of irresolvable conflicts of values, right? Better somehow than when they went in to see the theater. Okay, this is one example. I have other examples, but one example where maybe there are ways to come out and find a way to make a living together in the same city, let's say, without changing other people's minds about what's the right thing. Okay. Where you kind of respect that there are these differences of values, and people retain those differences, and maybe working on some way where maybe we can keep in mind the other people's values that are going to be different than mine, So we don't agree, okay? But we live together in some way. So that's kind of the kind of fundamental thing that I've been working with a lot of people. Okay. Now, the reason I say, so one thing about using theater rather than mathematics or logic or science is that, well, what are some techniques? What are ways to present a situation to each other that's got some poetry, got some, affective power, emotional power, right? Um, um, they represent relationships, let's say, um, but um, um, they allow multiple interpretation. Okay. That's so. Let me show you some techniques. Um, let's see if I can show some techniques. I'll give you some pictures, okay? Just to let's see if it can view inside, play inside window. Okay, good. Yeah, here we go. Let me share screen again. Okay, here we are. So, let's see. Okay, maybe I can show a funny one first. All right. Or let's show some big pieces first. Okay, this one. This is a famous work of art by an American Japanese couple, an artist, Arakawa and Gins, and they built this building. This is a life-size photograph. Okay, this thing here. um, if you go from the outside, you just see this gigantic tube stuck in the earth. When you walk inside the tube and come out from the bottom end, this is a dark end. You look up toward the sky. That white is the sky. You can see that you can walk up along the ramp, the slope of the tube, and you can see all around you this kind of surround. Okay, this right-hand picture with the red in it is more clear. Can you sort of see from through your screens what's on these walls and ceiling? Can you make it out?
It's a little bit
So it's how.
fuzzy, but like rock structures.
Yep. And then there are benches up in the ceiling. There's a bench up there. There's a bench here
Oh, it's kind of
in the middle.
mirrored.
It is weird. And then there's the walls. Chieko, I wonder if you can tell because this is referencing certain landscape form.
Hmm.
It maybe can't tell on your screen because it's too small. The walls are raked sand. You can see the grooves.
Oh,
It's
oh, I
raked
see
sand.
around one of the rocks, the closest one. I can kind of see
Yeah,
the line.
and these rocks are it's Japanese rock garden, basically. Japanese rock garden, very finely raked sand, but it's wrapped into a cylinder. And this is life size. These are people. Okay. So that means this is not a flat garden. It's a completely wrapped into a tube garden, gigantic. Okay. So here's the question: why did they do it? Why? So what's different between this and a traditional rock garden, Japanese rock garden? They have the same elements, sand and rock, etc. What are the big differences? Obvious differences.
Well, yeah, go on.
It's a cylinder.
It's not flat. It's a cylinder.
Yeah.
What else?
I believe typically you can interact with your normal gardens.
Imagine if you were trying to walk up along the walls here, right? What would you feel?
Like you're falling.
Yeah, the gravity would change, right? Because you walk along a Japanese rock garden, just level ground, right? Just walk and walk and walk and walk. But here, if you walk up toward, let's say, this rock on the right-hand side, at some point you're going to feel sliding off. In other words, gravity is no longer pointing down to the floor because the floor itself is curving. So this is an amazing way to change the direction of gravity. Gravity is no longer perpendicular to the earth, to the ground, right? With no technology. Also, look at the sky. Look at it's black or white, basically, right? There's no horizon. There's no horizon. If you go outdoors and look, basically any kind of landscape, you see a horizon where the sky meets the earth along a line. So this is amazing. This is amazing work of art that does what I call phenomenological experiential experiment. It changes the way that you perceive your environment. So this is an example of some extraordinary work. There's other work like that, which we don't have time to look into right now. Okay. So here's a small one that involves some interactivity. I'm going to run it now. So I asked my students, I showed them this kind of work. I asked my students in an architecture and media course, say, suppose you take a busy corridor in our university, this is back in Concordia in Montreal, and you see, you can use any kind of techniques, use computers and video, interactive programming, etc. But what I would like you to do, I said to them, is to change the way that the hall, the space responds to people as they walk through it. You know, it's pretty echoey, it's concrete, you know, and glass. But change the way so that it would, instead of people just commuting and rushing out of the subway to get to class, okay, change the way the environment responds to people so that they will be inspired to be playful. Okay, right in broad daylight in front of all these other strangers. And here's what they did. Here's what my students did. You hear me sound? Wait a minute. You don't hear sound, do you?
Oh, no, we can hear it.
Uh-oh.
Mhm.
Oh, okay.
No,
Let me
we
make sure
can
that-
hear,
yeah,
we are
sound's on.
able
Okay,
to,
let
it's
me-
okay.
Okay, here we go. See what they're doing? So you see what they were doing though?
Yeah, that's funny.
They put bubble wrap on the floor so that no matter what you do, just walking across the floor caused bubble wrap to pop, right? So they made the space interactive by just putting bubble wrap on the floor. They didn't use any computers. They didn't use kind of computers or media production. I mean, we had all that stuff. Okay. So that was very clever. Well, you can only do it once, right? Of course, lay out another sheet. But it was a way to take a given public space and add some responsivity to it. In this case, if you put a footstep on the floor, foot on the floor, you hear the pops that you wouldn't ordinarily hear. Okay. This is a very simple example of making the room respond to any kind of activity. So people didn't have to be told, do this and this and this, or push this button, then you hear a pop. No, because that would be really crazy complicated anyway, boring. But instead, just walk, just people just doing their, whatever they're going to do anyway, okay? And that activity is augmented by our media system, in this case, bubble wrap, so that their ordinary gestures get more interesting, become charged, okay? So this is a baby step toward a much bigger issue, okay, which is how do we make some kind of environment so when people get together and they start doing whatever, if we making dinner together or negotiating a peace treaty or planning a hydroelectric dam or you know, that the activities we're going to do anyway, all right, are enriched, supplemented, augmented in a way that makes them more expressive. Okay. So I'm going to show one more picture of work at ASU. Let's see if I can find it. Right. Okay. Yes, yes, yes. Two weather systems. Ah, here we go. I think right. Yes, I think it's will work. I'm going to show you now. Okay, let's hope this can run. Okay, I'm going to now share screen again. Like this one. So we worked at Synthesis with the National Center for Atmospheric Research, which is the main center of the United States for doing work on the weather and climate. Okay, and we took their scientific models for the weather systems, like the temperature, humidity, flow of the wind, what direction the wind is, pressure, all these variables, and the scientists use it to model the weather, to give you these kind of hourly or daily weather reports, which are enormously complicated programs. Okay, and there are even bigger programs that model the whole planet, and we use those programs to make predictions about climate change. Okay. But we took those models, the mathematics behind it, we implemented it in our system so that it's real time. Meaning, as soon as you start moving, we take your movement or your presence on the floor as if your body of moist air or hot air or your wind blowing across the floor. So here's what happens. So as you walk across the floor or put anything on the floor, like a rope or box or something like that, the system interprets the movement or your body as, like I said, as a body of mass of either temperature, moisture, or air itself. So when you start moving, basically you are becoming the wind. You become the weather because if you go like this with your hand, you're actually pushing the air around. And could be a scale where it's like hundreds of miles. So if you take a couple steps, it's as if you're walking across the eastern seaboard of the United States. Or if you take a jump, you might be jumping through the Sahara, right? Sahara Desert. And the system in real time computes what's happening to the air as you move around. So we can use this for scientific purposes. We can use this for dancers, which we've done. We can use it so that people can make experiments on the weather themselves. You see the difference? This is not watching somebody's movie. You are making the weather, and you can make your own experiments with it. So here, you see black squares? Those are pieces of metal.
You're actually not sharing your screen right now.
Oh no, hang on. Thank you for telling me that. I wonder why. Let's stop. Maybe because I'm in a different Zoom. Let's try again.
Okay.
Do you see the blue now?
Yes.
Oh no, sorry. Here we go. You see people walking around in a circle?
Yeah.
All right. Do you see all that stuff happening? It's not a recording. It's actually creating the weather as you move. It says those people walking in a circle, that means they're pushing the air around and around in a circle. And then the white shows the cloud forming under your feet because you are the cloud, right? The black loop is just a piece of black rope. And the scientist, Brandon, he just picked it up and moved it aside. So you see the flow of air cleared out the moisture. I put another barrier there right now, a straight barrier. It's a physical rod. It's as if you put a line of mountains there, and then the moisture is sweeping over the mountain and turns into cloud behind it, for example, right? And here's putting two rows of mountains, and in between there's a gap. And that gap is where the moisture falls through and forms this long streak of white cloud behind it. So you can play continent. You can be mountain range. You can be moist air. You can be temperature. Do you hear some music, by the way?
Yeah.
Okay. That music is actually synthesized not from the people. It's not recorded. It's music created by the movement of the air. So we can sonify basically the way the air is moving, or moisture, or pressure. Yeah. And here, where these are black squares, those black squares, wherever we put the black down, it can interpret that as a fixed, like freezing temperature or low pressure. That way, we can move those squares around and literally change the ground conditions. And this is the way that, using some scientific models, we can have anybody. Could be a weather scientist, could be a kid, could be a student, could be a economist, who knows, right? A journalist, who can then say, oh, let's try these different scenarios out. Okay. And here on the vertical wall, so you can see slices of the atmosphere. The floor is top-down view. The wall shows kind of the vertical slice of the Earth's atmosphere from ground level up to the height. And see the white that's appearing at the top of where the arms are? That's because the air has condensed, gotten cooler, and turned into cloud. There's a lot more we've done with other kinds of complex systems, like city heat maps, a heatscape for Arizona and for Phoenix, okay, where people can literally, with their movement, right, um, explore this complex system.
I emailed you about this, but I have to leave a little bit early today.
Yes.
But thank you so much. Talk to you soon.
Well, just in time.
I know.
Got the gist of it. Okay. See you.
Bye.
And Chico, I won't keep it too long, but maybe I'll say a little bit more to wrap up with you.
Okay.
It has to do, one of the readings has to do with the difference between performance and representation. Okay. And that'll be one of the questions, I think. Basically, what's the difference between just showing people a video of the weather or a video of the city, right? Or some sort of recording, it could even be a story, versus letting people enact the activity of whatever the system is. Okay? And I just showed you a few examples, but you can make up that kind of distinction all sorts of ways. All right.
Okay.
So hopefully, this is kind of an opener, all right. But maybe you can begin to think. Just quickly, can you give an example between making a representation of something versus doing it from your own experience?
I guess I'm not sure if this is exactly what you're going for, but just the immediate example that came to mind is, like, for example, in science class, they tell you to write out the instructions for how to make a peanut butter sandwich, versus actually following through and trying out those instructions and seeing where you go wrong. So that's like kind of those elementary type of science experiments. I feel like that's what immediately comes to mind.
Yeah, that's a good one. Or something involving a skilled activity, like, I don't know, do you play an instrument or some particular sport?
Yeah. I used to play a little bit of the koto, the Japanese harp.
Oh, wow.
I was in high school a while back.
Hard, difficult and beautiful. So and you practiced it. You had to practice it, right?
Yeah.
So imagine the difference between watching somebody else play koto, and then trying to do it yourself, right? You can watch all sorts of videos of it, and it might help you, right, get some overall understanding. But in order to learn how to play it, you have to play it.
Right.
You have to actually sit down and put your hands on it and play, think, move, practice. So that's the difference between, like, seeing a representation of somebody performing on the koto and then practicing it yourself and getting better at it. So that's a strong example. Okay.
Yeah.
Any last questions for today?
No.
Okay, well, I'm glad you were able to take a peek at it, and I hope this gives you a little bit more of a leg up on the rest of the reading. Okay,
Yeah. Thank you so much.
take care. Bye bye.
Yep. Take care. Bye.